Well, that was a really interesting talk. Firstly, thanks for having me. It's a real privilege to be here. My name is Phil Stubbings. I'm a lead data scientist at the Data Science Campus, which is part of the UK Office for National Statistics. I'm here today because I'd like to share with you some of my recent research, which looks into ways to extract economic and social insights from internet traffic data. So before I begin, just a little bit where I'm from. So the Data Science Campus is a new addition to the ONS that's formed in the later end of 2016. The main idea is to bring more sort of cutting-edge data science to the ONS and sort of wider government. We're mainly an experimental research group. We have shared expertise in machine learning, AI, natural language processing, computer vision, deep learning, computer science, and statistics. We work across a number of areas, including economics, environment, urban analytics, and so forth. So the project I want to talk about today is part of a much larger program of research, which aims to look at the possibility to use alternative or novel data sources for measuring the internet or the modern data-driven economy. So to start with, I mean, this is a really sort of open-ended project, but I've been looking at using data available from the LINX traffic flow portal, which I'm sure you're all familiar with. My general idea with this is that it may offer some a proxy view or a window view into overall internet activity. Because it's quite an open-ended project, it's been split into three different components. So the first component is I've looked at ways in which we may use this data to measure internet time use. And the second component is focused mainly on anomaly detection and if we can detect large-scale events in this data. And finally, being at the ONS, I've attempted to compare the data with various established economic indicators. So conceptually, the idea is pretty simple. So if we think about the traditional sort of low-tech economy, we have the well-established indicators such as GDP and so forth, but we can also turn to alternative means for measurement. So think about the road network. We may assume that peak time traffic is associated with, it could be an unfortunate side effect of a thriving economy. So lots of traffic could mean high levels of employment, for instance. We could go a step further and maybe count ships arriving at ports. This may give us an idea as to trade flow. Or if we think about the more industrial sort of based economy, we know that office buildings and factories and so forth, they will have a fluctuating demand for energy power. So the idea is, can we apply the same sort of thinking to measure the internet? So can we substitute cars, ships, or kilowatt hours for IP addresses and packets of information? So the idea is that can the actual flow and the amount of data tell us anything about the internet economy? So as I mentioned, I've been using data I've obtained from the LINX status monitoring platform. So this visualization shows 3 years of data focusing on the LON2 exchange. On the x-axis, we can see the day of the year, and on the y-axis, we can see the time of day. And it's delimited by 288 5-minute intervals. I'm showing this because already we can see some interesting patterns that sort of inspired me to look at this data. So at the very bottom, we can see this period of time where internet traffic is very, very low. So that's the sort of 3 o'clock to 4 o'clock in the morning period. And then if you look very carefully, there are these two bands of high intensity, which occur usually around the hours of sort of 4:30 p.m. and, of course, the well-known one at 9 p.m. I find the first band, which occurs at 4:30 p.m. to be really interesting, so I'd be really keen to hear anybody's insights as to what that may be. I have my own ideas, but so in terms of the overall trend, so I'm going to start with the sort of bigger picture and zoom in a bit. So in terms of overall trend, referring specifically to the London 2 exchange, year on year between the years of 2012 and 15, there was 24% growth on average in the amount of data generated on that exchange. And that settled down a little bit to around 7% on average per year between 2016 and 18. At the ONS, we have a survey known as the Internet User Survey, and it just counts how many people have access to the Internet. So during the same period, it reported that there was 2% growth year on year between 2012 and 15. But it interestingly also settled down to a 1% per year between 16 and 18, which is probably due to sort of saturation point because of more or less everybody has access to the Internet now. If we look at the monthly characteristics of the data, we can see that summer tends to have a lot less internet traffic, and in the winter months it tends to be a lot more, at least with this exchange. So we can zoom into the average day. And what strikes me about this data so far is that it's the result of human interactions with the internet. So what we can see here is the average day. So along the x-axis is the time of day, and the individual lines represent the average value for that particular time of day for each day of the week. But the overall pattern is the human harmonic. So in other words, this is a representation of the human sleep-wake cycle, which I find really sort of interesting component of this data. So referring back to the presentation we just had, I wonder how this may look in sort of 20 years' time. Maybe this human harmonic pattern will disappear as the sort of rise of the machines occurs. So from this we can see on average the middle of the weekday tends to be a lot higher than compared to the weekends, but I think that's quite well known fact. Besides the more obvious features, there are some more less obvious. So I'll sort of enumerate a couple of them here. So the first one is this morning dip in traffic. So it tends to be a lot higher on Mondays. A lot higher on Wednesdays compared to Monday. But the interesting point for me is the point in time when this low point occurs. It tends to fluctuate throughout the week. So on Wednesdays it tends to occur at about 4 a.m. and it goes all the way up to 5 a.m. at the weekends. I think that's quite interesting if we think about the different IXPs all around the country and indeed the world. Maybe we could compare the different characteristics between them. So this is the sort of 4:30 p.m. peak that I mentioned before, one of the features I find most interesting. And it's interesting because it happens around 4:30 p.m. each day, and which sort of coincidentally seems to be the end of the working day. So if I've assumed that this is actually delimits the end of the working day and remarks the start of the sort of commute home, and it tends to occur quite much earlier on a Friday and later on a Tuesday. And interestingly, we can see that the Friday traffic levels, sorry about the colour scheme, but it's the sort of magenta line in the middle of the time series there. So the Friday data seems to drop off a lot faster compared to the rest of the week. So this may be due to sort of social or non-internet related analog social activity.
We call that Skyping.
Oh really? Yeah. Yeah. So I think this one is well known. So I think it's what's considered to be internet rush hour, as it used to be known a long time ago. So it's not much. It's not very interesting. It's very static. It tends to occur about 9 p.m. every single day, with the exception of Sunday, where it's usually about an hour. It occurs an hour before. So I took these initial measurements. I thought, okay, how can I use these to potentially measure internet time use? So, as I mentioned before, what I find fascinating about this data is that it's the result of human interactions with the internet. So, can we sort of measure large-scale human behaviour? So, some of this has been done already, but it's a really interesting idea. I looked at the 2015 time use survey. And so the time use survey just asks you what were you doing every day. So you're obligated to keep a diary. So this would include where, if you were working, and indeed what you were doing at work, and so forth. So the graph on the top right-hand corner shows the number of people reported to be working on average throughout the working week and the weekends. And the graph on the top left-hand side is the average LON to internet traffic for that same period. So I'm showing this because I think that there may be a link between this midweek increase in traffic and labour force participation, perhaps. The time use survey also asks you, if you were using, if you're watching TV and so forth at particular times in the day. So if we line up the average internet day from the LUN2 exchange with the average reported behaviour in the time use survey, we can see that they're very much in line. And interestingly, the reported device use, which includes the use of a computer, lines up very nicely with the so-called evening peak time traffic. So this is really interesting because I think that so time use data is really useful for social studies and indeed understanding how the economy works. And of course, it's like a really low frequency sample. It happens with a traditional survey. So I think potentially there's potential here to use this data to estimate some of the parameters in the time use survey. So I think it's potentially useful. So I went a step further. So if we take the average internet day, we could potentially divide this up into different regimes or phases. So the first phase, before I've identified various points in the day where there's a change in the traffic. So I've used a change point detection algorithm to detect exactly where the traffic changes. So I've managed to detect these 4 different points. And then I measure the distance between these points and interpret them as phases. So the first 2 points, A and B, I interpret this as being the sort of internet working day. I refer to that in a very sort of informal way. And the distance between point B and D, so the distance between the 2 peaks at the end there, I refer to that as the kind of post-work leisure time /eating commuting phase. So we measured how these phases change through time, and on average we find that the length of the internet working day tends to be a lot shorter in the summer months and longer in the winter months. Is it okay if we do questions afterwards? And then the length of the leisure time tends to be a lot sort of longer in the summer months, which, if this is indeed a measure of this, it tends to sort of suggest that people are making more use of available daylight and maybe related to better weather conditions and so forth. So the next part of the project was considering special events such as adverse weather conditions. So to do this, we constructed a time series forecasting model based on a technique called singular spectrum analysis. And the general idea is, can we forecast what the value of traffic is going to be in the next 5 minutes? And then we take the actual observed data in the next 5 minutes, and the difference between our predicted value and the observed value we interpret as being the unexpected or unexplained internet traffic. So if we apply this technique to all of the time series data, we were able to identify a number of events. So if you remember last year, there was a period of cold weather called the Beast from the East, nicknamed this, and inside this period there was a winter snowstorm called Storm Emma, and it's produced some quite heavy snowfall. On 2 days this fell on London, and the effect of this was that there was an increase in internet traffic on those 2 days, which was marked by point A and B in the top chart. So the bottom chart shows the amount of traffic which was an anomaly, or we couldn't explain that traffic. So this is a similar representation. So this could be the result of people working from home, or looking for more sort of up-to-date news. So we also looked for the same effects in different types of data sources, so energy demand and also road traffic data. So we can see the same effects elsewhere too. As a long shot, we thought, can we identify any large-scale retail behavior? I appreciate that the data is highly aggregated and really small events are probably swamped by streaming and so forth, but we looked to see if we could identify the obvious one being Cyber Monday. So we can see an anomaly on Cyber Monday in 2018 at least. However, we couldn't find the same effect in the previous years. Whilst the effect was significant in comparison to the rest of the anomalies, it's difficult to say if that is actually the result of Cyber Monday, and likely isn't because of the other anomalies occurring at the same time. So this is a really well-known effect, but I've managed to reproduce it here. And I found out yesterday, while watching some of your previous videos, that this has been discussed before. It's really interesting. So the top chart shows the recent semi-final between England and Croatia, with the added extra time and so forth. So in this example, there is a marked decrease in the internet traffic, and you can see the half-time, of course. And in the traffic then returns to normal after the event. But interestingly, the England versus Sweden game had the opposite effect. So there was actually an increase in traffic rather than a decrease. I suspect that the first one, didn't actually watch it myself, was a televised event, or the type of event where you'd sort of watch it in a pub or something like that. So from all of the events we managed to detect, bank holidays tend to have the highest impact. So on average, a bank holiday in this data tends to have a sort of minus 7.8% decrease in the expected traffic. The highest impact bank holiday tends to be Boxing Day, which on average is a 16% drop in the traffic. And the Christmas period tends to have the longest sustained impact on internet traffic. And this is interesting for me because if you think about bank holidays, we can assume that most people won't be working on those days. So potentially the difference between the traffic on those days is an indication as to workforce participation. And if we could track the differences through time, it may be sort of related to employment levels or productivity and so forth. So I find this potentially quite an interesting event type to look at. So this is how a visualization of the anomaly detection mechanism applied to a year of the data. So the top graph shows the higher than expected daily traffic levels. So on the x-axis we have the day of the year, and the y-axis the day of the week. The middle chart shows, so it's the other way around. The top chart shows lower than expected internet traffic, and the second chart shows higher than expected internet traffic. We're able to identify lots and lots of anomalies throughout the year. And we're able to associate some meaning to them, but a lot of them are unexplained. So, for instance, the highlighted one in the middle was exactly a year ago on the 30th of May, a really high increase in the traffic, which I couldn't find any associated news event with or anything like that. So we're interested to see if anyone has any insights as to what that could be. The final chart on the bottom right-hand side shows days where there was significant sustained abnormal internet traffic. So the amount of time where the internet traffic was above or below a predefined threshold. So this is quite useful to pick out really high impact events. So in addition to the sort of adverse weather conditions, and sporting events and so forth, we're able to identify political events. So we looked at the general election. There was a marked decrease in internet traffic on that day, on polling day, and a slight increase in the evening afterwards. We also identified major news events. These tend to be more sort of spiky in behaviour. and also network-related events. So there was an event on the 6th of December 2018, which which happened to be the same time as the O2 network disruptions. Whether or not this is related, I don't know. So just to summarise, so this has been a sort of really experimental research. The general idea is it's part of a wider work programme where we're looking at different ways of measuring the internet-based economy. So we don't have any measures at the moment which are sufficient to measure the effects of the internet, beyond, of course, looking at it in terms of a service. I believe that the IXP data has got huge potential to reveal insights into large-scale human behaviour and indeed aspects of the economy. We've got a technical paper coming out soon, which is in progress, so that will be on our website. That's it. So thanks for listening. I really appreciate. I'm really keen to hear any sort of ideas, comments, or suggestions you may have. Thanks.
Okay, just right. How many hands up have we got up? One. Oh my God. Right. No one's having lunch. One, two, three. We were not going to be able to do all these questions, guys. Let's get started and see how we get on.
Shall I start?
Yeah.
Hi, Simon Lockhart. I'll speak on behalf of Glide. Two observations. One, in your anomaly events, one of the things you might want to consider is sort of patch days or software releases. So we certainly see big spikes when Apple release new software versions and things like that.
Yep.
The other is when you look at your internet time use data, have you started to consider different demographics? I say that because I run an access network for university students, and our peaks and troughs are offset by almost exactly 2 hours from what you see in the aggregate data. So our lowest is 7 a.m., our highest is about 11 p.m. We also see a slightly different peaks in days. We see Fridays and Saturdays are quiet, but we actually see Sundays are quite busy, which we think is sort of students coming back after a weekend away, or they've run out of money for socialising at the weekend and things. So.
Are you from JISC?
No.
Okay. But yeah, that's really the last point. That's definitely something we're looking at. In terms of academic networks, so at work we're interested in emerging technologies and how we can measure that. So research is a really important part of that sector. So looking specifically at an academic network, if we could isolate that, would be really
I represent sort of the social bit of students, so student accommodation, and James over there represents the academic side. So more than happy to work with you to provide some data if that would be useful.
Great. One thing we thought about doing was that drop-off in traffic which occurs on a Friday afternoon. I mean, if you think of the difference between London and Manchester, you might be able to argue that Manchester is more of a student-driven city. So perhaps that drop is more and can provide some insights as to sort of different levels of very high-level sort of social activity. But so your first point with respect to backups and so forth, I noticed on the Man1 exchange in 2017, I think when there was a lot, maybe there was less connectivity there. There seemed to be these, around, if you can see in the dark band at the top, these sort of spikes of behaviour which occur in a sort of staggered sort of pattern. So I'm guessing this is off-site backups or because they're happening in the early hours of the morning, or indeed software updates. But with respect to that, one thing we're thinking of doing is characterising the sort of classifying the characteristics of the time series data. So as I mentioned, some events tend to be spikes, some events tend to be more sort of parabolic in nature and so forth.
James?
So, James Blessing from JISC. A quick question about, do you have children of your own? because if you look at the pattern in the early afternoon, that's not people skiving off work, that's the kids getting home. And then the dip you get about 6 o'clock is when they go for their tea. If you've run an ISP that has lots of families on it, you'll see that your pattern of traffic will shift subtly at that point in time. The other one you've got is you've used LON2. Was there a particular reason for using LON2 rather than LON1? And you are aware that there's an awful lot of data that doesn't go across the Internet Exchange that is coming from what would be classed as CDN, so the more, business-focused traffic.
Yep. So firstly, I'm an IXP sort of newbie. I looked at all of the different exchanges in isolation, and when I looked at LON1, has the highest amount of traffic, on the daily average, it didn't have that evening sort of peak. So the first thing I was thinking is that it just doesn't seem as interesting in terms of its characteristics compared to LON2. I made some assumptions that perhaps LON2, given the idea of IXPs, is more associated with the intention of the IXP to keep the local traffic local. Maybe it's associated more with local traffic. I assume that there's a lot of international traffic going through LON1. But we have included LON1 in our analysis, which will be in the technical report. With respect to the peaks, so my own idea, which is related to what you just said, is that these two peaks at 4:30 p.m. to 9:30 p.m., I think the distance between them may have something to do with commuting behaviour. No. Okay, that's interesting too. So I've compared the LON2 data to road sensor data from the M25, so the inner circle actually of the counting traffic on the slip roads. There's some relationship there, but as I said, I've made a huge assumption here that it's related to commuting behaviour. Okay.
If we could just have Ivan, then Neil, then Mike, and then two more at the back, and then we'll move on.
Ivan Beveridge from IG. I was wondering if you had looked at packets per second rather than data throughput, because of the potential skew for high traffic like video streaming, that kind of thing.
Yeah, I've only looked at the actual amount of bandwidth or throughput, but that's an interesting point. Because some data can completely swamp other data, so it's definitely something we're going to do. But in terms of the average characteristics, the time series appears, at least visually, to be the same. Thanks.
Rupert Fines, Digital Realty. I'm just wondering, my colleague actually made a very pertinent point about PPS, but I'm sort of wondering whether you actually thought about closing the loop on this a bit to have confirmatory evidence. Some of the organisations like Netflix and the BBC obviously have specific ports on LINX, and you can perhaps come up with confirmatory evidence that something is down to a streaming event or whatever else on that basis. Did you consider that, or are there privacy considerations that might have prevented you from getting that data?
So to address the privacy consideration, that's one of the appealing components of this data. It's very simple. It's just a timestamp and a really high-level aggregated statistic. But as I mentioned, we managed to identify loads of different newsworthy events. And so far, we just sort of correlated them with the sort of list that you can obtain from Wikipedia. But it would be interesting to sort of to see the traffic statistics in terms of like Google Analytics behind major news sites such as BBC News and so forth, to see how they stack up against this data. Perhaps we could make a correction to isolate the individual patterns.
Neil?
I've got so one thing I just watch out, because the sample size for the LINX is actually quite a small sample. So LINX is 4 terabits. I think the 3 biggest access networks together is 36. So your sample size for the whole of the UK, I think, is quite skewed. But actually, and then when we see what we see on the mobile network, from people going from work to mobile to home, is we see a correlation between people downloading and caching stuff just before they leave the office. So they're downloading something from iPlayer or from Netflix offline so they can watch it on the train. And we see an absolute kind of you know, we can almost pick the times, and I think from what's on that, it looks very similar. And then I think my final question is, why are you doing this?
Okay, I was afraid somebody would ask that. So, as I mentioned, there are like an experimental research unit, which is part of the ONS. If you think of the economy at the moment, I mean, the way we measure it is with some really sort of outdated, I have to be really careful what I say here, some really sort of outdated ways to measure the traditional aspects of the economy. So the more sort of factory-based, production, service-based version of the economy. So we're interested in...
the efficiency of the economy.
So the more sort of supply-demand-driven aspects of the economy. So I'm saying that we haven't done a great job at measuring the impact of the data-driven or internet economy. So we're looking at different types of potential indicators which could help in this sort of larger project, which looks at ways we can measure this, which would include measuring internet infrastructure. But
things like Royal Mail packages per day.
Yeah.
And correlating that sort of data.
Yeah, to the traditional sort of low-tech version of the economy. Yeah.
Remember that half of transactions turn into on a Sunday night. We believe half transactions are to Amazon people buying stuff just based on what we see. That then there's then how that filters through the rest of the economy, supply and demand.
Yeah.
And I think unless you bring those components in, you probably just have an interesting bunch of, there was a football match. Because it's really hard to take it further than that without that correlation.
You're right. I mean, the tangible in the economy does intersect with the intangible by logistics networks. And we can't use indicators in isolation, which is correct. So what I've done here, I've gone straight to the source. So the shared characteristics between the, rather than going in the application layer and looking at counting products available on websites and so forth, I've gone straight to the source. So the shared characteristic is transmission of data. So this project is really, can we actually identify anything useful in this data source and related data sources? And the results so far tend to suggest that there are some interesting insights which can be potentially used. So the ONS is mainly a survey-driven organisation. There's a business survey which goes out periodically and it asks businesses, what's your connectivity? How many of your employees use the internet on a day-to-day basis and so forth. We could gain that information by looking at peering DB or doing a DNS lookup on the company's IP addresses to see if they're using cloud infrastructure and so forth. So these kinds of data sources could potentially replace the more sort of traditional survey-based approaches, which tend to be really low frequency and, of course, contain a lot of error. So that is, we're looking for techniques which are more sort of scalable and can provide more real-time insights.
Mike, just quick, or do you want to grab Phil in the lunch?
I'll be really quick because I'm hungry too. Manchester. One thing to bear in mind with statistics from the Manchester pub, and I'm a proud Manchester resident, and the participant on the exchange with my day job hat, there is a handful of significant traffic consumers missing from the Manchester constituency, and they will only exchange traffic in London, and they are basically 3 of the largest eyeball providers in the country. Bear that in mind when you look. It is nothing about regionality.
Okay.
Because the people in Manchester have the same habits as everybody else. Yep. It is the fact that those people cannot and do not exchange traffic in Manchester at the moment.
Okay, thanks very much.
Great. Thanks, Phil. And you'll be around at lunch, will you, for other people
Yes,
to
definitely.
grab you? Excellent. Thank you very much.
Thank you.